Alright, we are going to begin Section A, single number ratios. Ratios are when you are comparing two items and both have numbers attached to them. Those items must be related. And we're talking about carpooling. If you do not know what carpooling is when you kind of share a ride with somebody. So instead of your mom bringing just you to school, she might bring you and 2 or 3 of your friends. Or if she's going shopping, instead of just herself, she might have 2 or 3 of her friends along. So either read by yourself or follow along as I read. The students in Mrs. Cole's science class are concerned about the air quality around Brooks Middle School. They notice that smog frequently hangs over the area. They just finished a science project where they investigated the ways smog destroys plants, corrodes buildings and statues, and causes respiratory problems. The students hypothesize that the city has so much smog because of the high number of cars on the roads. Students think that there are so many cars because most people do not carpool. They want to find out if people carpool. So they set up an experiment to count the number of cars and people on East Side Highway adjacent or right next to the school. One of the groups in the class spent exactly 1 minute and they counted 10 cars and 12 people. And they made a picture here of 10 cars and 12 people. Question 1A. How many of these cars could have carried more than one person? Give all possible answers. Before you answer it, you need to think. Did every car have to have one person? Why or why not? All right, now you may pause the tape, write your answer, make sure you echo the question. 1B, find the average number of people per car and explain how you found your answer. And if you notice, that is starred, and you know starred problems mean that we need to do a ratio table. So the two things we're comparing are the number of people and the number of cars. And we know that there were 12 people and 10 cars. So when we're doing this, it says the number of people per car. So they don't have a 1 there, but when it says per car, that means for every 1 car. So to go from here to here, we're going to divide by 10. To go from here to here, we're going to divide by 10, and we get 1.2. 1.2 is an excellent answer because 1.2 says, hey, you have more than 1 person per car, but you don't have 2 people per car. And it's actually closer to 1 than to 2. Using this information, go ahead and try to continue on 1 through 5. A little help on number 2. Number 2, the second and third groups each calculate the average number of people per car. They are surprised to find that both groups got an average of 1.2 people per car. How many cars and people might each group have counted? So on number 2, once again, we have a ratio table. In fact, we'll start this question for a ratio table, and we will have people, cars, and it was 1.2 to 1. So now we have 2 different groups. So we have our second group and our third group. And let's say we multiply this by 5. If we multiply this by 5, we have 6 people and 5 cars. Here we need a whole number. So this could have been group 2. You need to find one for group 3, a group of people and cars that work. All right, your goal right now is to finish through problem number 5. Be sure to remember to echo the question.